In this lesson, we're going to look at stationary points. So in the last lesson, we looked at when graphs can be increasing or decreasing. And if you differentiate and substitute a value in, you can find out if the derivative is positive, which means the function is increasing, or if it's negative, which means the function is decreasing. But in a stationary point, we say that the curve is stationary when it's neither increasing or decreasing. And this is when the derivative is equal to 0. So there's 4 possible stationary points. And we're going to try and find them by solving an equation set up by differentiating and letting the expression equal 0. We have a maximum stationary point is here. A minimum stationary point's here, so these are called turning points, you've seen them before. There's a rising point of inflection, so we have increasing function to the stationary point and then increasing again. This is a stationary point here. Or we have a falling point of inflection. This is the stationary point, so the function is decreasing to the stationary point and then decreasing again. We can find either whether the function is a maximum, minimum, rising point or falling point, again by solving f dashed x equals 0, and we can work out what the nature of the stationary point is. Now to do this, we examine the graph's behaviour just before the stationary point and just after. Okay, let's look at the first example. Find the stationary points on y equals x squared plus 3 and determine their nature, i.e. determine whether they're the stationary points is a minimum turning point, a maximum, or a point of inflection. So the first thing we do is we have to set our working out clearly and neatly and tidily into different sections. So firstly, we'll differentiate. So dy by dx equals, take the power down, reduce it by 1, so 2x. And you have to write this sentence out. It's worth a mark, and if you don't include it, you lose a mark. Stationary points occur when the derivative is equal to 0. This is when the gradient is equal to 0. Okay, so you let 2x equals 0. This is you setting up the equation, and you solve it. So that means divide by 2, so x is 0. And then we have to work out the y value of the stationary point. So that's the x value of the stationary point, x is 0. You substitute it back in up here to y equals x squared plus 3. So that's 0 squared plus 3, which is equal to 3. So the stationary point in this case is 0, 3. Okay, the next thing we do is we draw a table. This is called a nature table to find out what type of stationary point this is. This will let us know if it's a maximum, minimum, or rising or falling point of inflection. So in your nature table, you always have the same thing. You have your x value, you have your derivative, and then what the slope looks like. So to fill this out, in the middle we use our stationary point. We know x is 0 as our stationary point. We look at just before 0 to see what's happening. I would just choose -1. And a wee bit after 0 to see what's happening, I would choose +1. To find the derivative, we've already done that up here, it's 2x. Now we substitute in these values here into the derivative to find out if they're positive or negative values. This will tell us where the graph is increasing, where it's decreasing, and then that will eventually tell us what the graph will look like. Now the derivative when x is 0 is always going to be 0, okay, because that's our stationary point here. So the gradient's 0 at the stationary point always. To find out what happens when you substitute these values in, we do that working at the side. So x equals -1, the derivative equals 2 times -1 because the derivative up here is 2x. So you're putting -1 into this, and that comes out as -2, which is negative. So that would be a negative there. And at x equals 1, this is this point here, we substitute it into the derivative. and that's going to be 2 times positive 1, which comes out as 2, and that is positive. So if you were to draw the nature table or sketch out roughly what the graph looks like, negative is going to be sloping down. This is your stationary point, so that's flat, and positive's going up. So thinking about the previous screen, this looks like a minimum turning point. So we've worked out the coordinates of the stationary point. Now using the nature table, we've worked out what it looks like. So we have a minimum turning point at 0, 3.